Hello, welcome to the second episode of this complex number series. Today we're going to be looking at the polar representation. And so the first thing we really want to consider in this video is the argument of a complex number. And so the notation for that, say we have our complex number here. The notation for the argument of the complex number is just argz. And essentially this is going to be giving us the angle between the x-axis and the line between 0 and z. And note this is measured anti-clockwise. Okay, so that's essentially theta is going to be equal to argument of the complex number and r, which we disclosed before, is equal to the modulus of the complex number, which remember is equal to the square root of x squared add y squared. So let's consider a point on our plane here, a certain x and a certain y coordinate with an angle theta. This length is obviously r, the distance between z and the origin. And so what we can quickly find out here is that x is equal to r cos theta and y is equal to r sin theta. And almost as importantly, tan theta is equal to x over y, and that's literally just dividing y over x, and that's literally by dividing say this is equation 1 and equation 2. If we divide 1 by 2, we get this. Okay, so why is this useful? Well, say we would like to find the argument of this complex number here. We're just going to do 1 at I. Well, first we need to find theta, right? Because we know that the argument of theta equals z. So how do we do this? Well, theta can be found by doing theta equals arc sine of y over x. Well, our value here is 1 and 1, so 1 divided by 1 is arc tan, sorry. And this should be equal to pi over 4. And so this argument. However, if we were given this complex number instead, so we've got negatives here, would our value of theta be pi over 4, or would it be in fact 5 pi over 4? Essentially we're going to need to draw a graph to find this out, because for one at I, where we're looking in this plane here, but for -1 minus I, where we're coming down here, so we actually need this angle here Right. So what we've essentially got is pi over 4 add 180 degrees. What's 180 degrees in radians? It's pi. So we've got our theta add pi here, and this is going to give us 5 pi over 4 as our argument. We'll make this a little bit clearer. Our argument of our second complex number is 5 pi over 4. So let's try and think about this in terms of the polar representation. So the polar representation is essentially expressing our complex number in this form, which its utility will be disclosed in very near episode, but not today. And note also that the complex conjugate can be written like so. Okay, so say we're given this complex number again, z equals 1 add I. Well, we already know our argument is pi over 4. And what else do we know? Well, we need to find r to write to give this complex number in its polar representation. So r is going to be equal to the square root of 1 squared add 1 squared, which is root 2. So therefore, this complex number can be written as root 2 cosine pi over 4 add I sine pi over 4, like so. This is essentially a simple concept of polar representation, which comes in very handy in the next few videos.